The focus today is acceleration. Acceleration means speeding up. And the problem is, why do the cargoes go the distances they go? A cargo is something that a truck hauls. Okay, and then we'll write a conclusion here. On the bottom half of your cargo paper, you want to put this data chart. You'll have a column for cargo, a column for distance, and then I'll tell you later what goes in this column. And I'm going to try cargoes A, B, C, and D. Okay, this is my acceleration table. I need a long, smooth surface with no cracks. And most schools don't have a surface like that, so I bring my own. Okay, here's my acceleration cart. It's a little matchbox truck with a plastic hook on it. I accelerate the cart with this rubber band by stretching it. And these are my cargoes, A, B, C, and D. 4 of them. Okay, now I have to get this set up with A first before I try the other cargoes. And Tia, will you stand right at the end there and hold your hands against the end so the cart doesn't run off the end? What I want to do is set this launch pad just so that the rubber band stretches enough to make the cart go almost to the end, but not quite. Don't touch it if it doesn't go off the end. If it doesn't go all the way to the end, don't touch it. Okay, here we go. Oh, a little too far. I can adjust how far the rubber band stretches by moving the launch pad. Okay, we'll try it again. Okay, good. That's all you need to do, Tia. Okay. Well, I have a ruler tacked onto the table here so I can tell how far it goes. And A went 78. So on the chart for A, right? 78. 78 inches. Now I'll try B. B went 69. Now I'll try C. C went 57. I'm not going to try D yet. I'll try it after we analyze this. If you look at those data, those numerical data, you should be able to see some, you can see that they're different. Now, the problem is, why do the cargoes go the distances they go? Who can think of a question that could help to answer that problem? What's something you need to find out? Something you need to find out, Jessica.
Is A, B, and C, are they different, different sizes?
Okay, do A, B, and C have different weights? Yes, they do have different weights. So already I have enough data to form a tentative conclusion because they all have different weights. That can be called valid and reliable because it's supported by that data item and it's not refuted by that data item. What does it mean if it's not refuted? When I say it's not refuted, what does that mean? It's not true or false, right. So we can call it valid and reliable, but it's not complete yet. Another question that needs to be answered is, why did A go the farthest and C go the shortest distance? So what do you need to know to explain that, Allie? What would you have to know to explain that? What else would you have to know, Jake?
Is A lighter than C?
Okay. Is A lighter than C? Yes. All right, now let me ask you a question. Is C heavier than A? I'm going to have you vote. How many say C is heavier than A? Well, you understand that because it's the reverse of that. But most first graders wouldn't understand that. They don't have that ability yet. All right, well, where does that leave B? Who wants to suggest where that leaves B? Emily?
Right in the middle.
So that would, what would the question be? What would the question be about B now? It'd be a double question. What would it be, Emily? Is B,
Heavier and lighter.
well, we look heavier than which one? Heavier than what? A, but lighter than B, and the answer is yes. Okay, well, we have a lot of,
B
we have a
lighter
lot
than
of
B?
important data. What can
Is B lighter than B?
What?
You put B lighter than B.
Should be C at the end.
lighter at the end. You put is B lighter than B?
Oh, good. You found me making a mistake. Well, I know that everybody who pointed out my making a mistake wasn't asleep, okay?
I said in my head.
Good. All right, well, we have a lot of important data here. So, that explains why they go different distances. How would you explain now, based on these data, how would you explain why A goes the farthest? Who can explain why A goes the farthest, Chase?
Because it's lighter. Because it's lighter.
Okay, how would you explain why C goes the shortest distance? How would you explain that, Ellie?
It's heavier.
So here's how we're gonna summarize that. Lighter. Lighter. Cargoes. Go farther. All right, and then if you turn that around, then your cargoes go less. Okay. Is this supported by the data and the chart?
Yes.
Yes. So not only is it valid and reliable now, but I'd call it a pretty good conclusion. But
Let's figure out B.
we haven't done D yet, right?
Yep. Yeah.
Well, I intentionally didn't do D yet because, oh, well, now that you know that A is the lightest and C is heavier, I'm going to tell you what their weights are. Now listen. Hear that?
Yeah.
Those are fishing sinkers, little fishing weights in there, little spherical fishing weights. Okay. A has none, B has 2, C has 4, and D has 6. All right. Who knows the manipulated variable in this experiment? In one word, give me one word that tells the manipulated variable. Jay, Tanner. Right. Weight is the manipulated variable. So everything else has to be a controlled variable. All right, now here's a question for you that you ought to know the answer to. The number of sinkers represents the weight, which is the manipulated variable. Are the sinkers all the same size? I'm going to have you vote. Are the sinkers all the same size? How many say yes? How many say no? Why does the answer have to be yes? Why do the sinkers have to all be the same size, Emily B?
Otherwise there'd be too many.
Otherwise, there'd be 2 manipulated variables. All right. Who besides Emily B can tell me why you only want 1 manipulated variable in any experiment? Why, Darby?
If you have 2, you don't know which one is causing the
Right. The primary reason for scientific experimentation is to find out what the effect of the manipulated variable is. So you only want one. All right. So these are sinkers. This column represents the number of sinkers. All right. Now I'm going to give you a chance to do some predicting. By analyzing the chart, you should be able to come up with a pretty good prediction for how far D will go. Look at the chart, and as soon as you're ready to make a prediction for D, raise your hand. Stevie.
40.
Stevie says 40. Okay, another prediction, different one. Mason. 48? 48, okay, one more, Shayla,
46.
46, okay, now those are pretty, that's a pretty good series. I'm really pleased to see that they're all less than 57. Why? Why should you know that it should be less than 57, Brandon?
Because the 78 or 69 is less than the 78, so the D has to be less than 56.
Okay, who can explain it a slightly different way? Why am I glad they're all less than 57? Nathan?
Because it's heavier than C, so it would have to go.
Okay, C went 57, and D is heavier than 57. Does the chart show that a heavier weight goes less distance?
Yes.
Okay, well, I'm going to have you vote on which one. Look at the chart, look at this, and then I'm going to have you vote on which one of these you prefer. You think will be the closest. How many think 40 will be the closest? Not even the person that suggested it, okay. 46. All right, 48. So this is going to be E minus what?
7.
What does E minus 7 mean?
Everybody but 7.
Everybody but 7. That's how you'd write it in algebra. Okay, most of you thought it would be 46. Well, actually, those are all good because they're all less than 57. Well, let's see how far D actually goes. $49.
Oh, yes.
Those are very good. Those are very good predictions. Now, I'll show you a way you could have. I'll show you a way you could have predicted it mathematically, which some of you might have done mentally. You can see that the difference here is 9. The difference between these two is 9. This was 9 less. This was 12 less. So this ought to be somewhere about 9 or 12 less. Well, actually, it's 8 less, right? So that's a way to predict it mathematically. A lot of scientists doing a lot of research make data charts based on what they can observe, and then they make predictions on the basis of what they can't observe. They do that a lot. It's a very valuable skill. Okay, well, because they all have different weights, lighter cargoes go farther. Who knows why lighter cargoes go farther? Why do lighter cargoes go farther, Jake?
Because if it's heavier, it'll weight it down, so it'll put more pressure on the wheels, which will stop us.
Okay, that's a very good explanation, but you didn't use the key word I was looking for. I was looking for a key word in your explanation. I'm going to see if anybody can explain it differently and use a word that he didn't use. That's the key word that it describes the relationship between the weight and the distance. What do you think it is, Emily?
Well, I think that because it's heavier,
it'll, like I said, it puts more weight on there, so it slows it down. But if it's lighter, it can like glide across.
Okay, that's essentially what Jake said. Anybody else want to try using a word that hasn't been used yet that you think might be the word, Jonathan?
Dance?
Well, no, that's not the word I'm looking, it has this many letters. See if your word that you want to suggest has this many letters. What's a word that tells why more weight causes it to go less distance? That would have that many letters. Anybody think of a word? What do you think, Jessica?
Distance?
Good, Jessica. Friction. Friction.
Yeah.
All right, now, if you don't know what friction is, rub your hands together. What you feel is friction. And you should notice that the harder you push, the more friction there is.
I don't want to do it.
Okay?
It's getting hot.
So,
That's disgusting.
I'm going to add a sentence up here that, I'm going to add two sentences actually.
I haven't even done one line.
More weight, this will be final for you, it's okay to copy it. More weight causes more friction. More weight causes more friction. Well, I guess I'm actually gonna have three sentences. Friction slows down moving objects. Friction slows down moving objects. Well, if friction slows down moving objects, why does your car slow down when you press on the brake pedal? Can anybody figure out why the car slows down when you press on the brake pedal? Jeremy?
Because the things press onto the wheel and they make friction, just like when you're rubbing, except for the
I'll draw a little diagram to represent that. Now, when I was your age, we had what were called drum brakes. Now golf cars have what are called disc brakes. But here's the way a drum brake works. If that's the wheel, and this is the brake drum inside the wheel. If you take the wheel off, you can see the brake drum. Okay. If you press on the brake pedal is like this. Okay, and it has a hydraulic, and on the old brake drum brakes, there was actually a cable in a tube that went up to here and pushed on what's called a brake pad. Well, when you pushed on the brake, that pressed the brake pad against the drum, and it increased the friction, and the friction slowed the car down. Okay, then disc brakes that are on modern cars are different. If you're looking at the